Hello everyone, welcome to Neso Academy. I am Shiv Sablok and I will be your instructor for the course Theory of Computation, which will be the part of semester series for computer science and engineering students. Now your seniors might have told you that theory of computation is a very difficult or complex subject. But believe in me, I will make this subject very simple for you because theory of computation is one of the foundational subjects of computer science. And this is the very first lecture of our course, that is Introduction to Theory of Computation. So let's quickly discuss all the topics that we will cover during this lecture. Our first topic is what is theory of computation, in which I will explain you the standard definition of TOC. After that, we will see the syllabus of this course, in which I will give you the chapters that we will study during this course. At last, you will see the target audience, basically the people who will get benefit from this course. In this section, I will also tell you the major course highlights. So without any further delay, let's start with our very first topic, that is, what is TOC? But wait, I will not directly jump into the bookish definition of TOC. Before that, I want all of you to give me the answer for this question. Can computers solve every problem in the universe? What do you think? Now, some of you will say that computers can solve every problem, while some of you will say that computers may not solve every problem. And some of you might also say that computers can solve every problem, but the time required to solve problems will be different. So which one is correct? To get the correct answer, we have theory of computation. So let's understand the formal definition of TOC. Here I have written, TOC is a branch of theoretical computer science that explores the nature and limits of computation. That is, what a machine can solve and how efficiently. Certainly a bookish definition, but I will decode it for you. Now you have to focus on this line first, which says that TOC is a branch of something called as theoretical computer science. Now, what is this theoretical computer science? It is actually a vast area of study in which we talk about the mathematics and logics behind the computers. In simple words, theoretical computer science is the area of study of all these subjects that are mathematical logic, automata theory and formal languages, number theory, graph theory, computability theory, computational complexity theory, cryptography, type theory, category theory, computational geometry, combinatorial optimization, and quantum computing theory. So these are all the subjects that comes under theoretical computer science. And we have just seen that TOC is also one of the part of theoretical computer science. But do you see TOC in this list of subjects? No. But why? We will come back to this question once we completely understand the definition of TOC. Till now, we know that TOC is the branch of theoretical computer science that explores the nature and limits of computation. Now, what is nature and limits of computation? Nature of computation means how computers solve a problem using a step-by-step approach. And what is limits of computation? It means what problems are solvable by computers and what problems are not solvable by computers. So TOC defines the nature of computation as well as the limits of computation, which means that TOC tells us what a machine can solve and how efficiently. Now, efficiency is also as equally important as the solvability of a problem. Because if a problem is solvable, we might also be interested in knowing how much time does it take to solve that problem. So, efficiency is also equally important. Now I hope you have completely understood the definition of TOC, which says that TOC is the branch of theoretical computer science that explores the nature and limits of computation, which means what a machine can solve and how efficiently. Now coming back to your question, where is TOC in this list of subjects? So actually, TOC is not just a single field of study. It comprises of three subjects of theoretical computer science. That are number 1, automata theory and formal languages, number 2, computability theory, and number 3, computational complexity theory. These three subjects together called as theory of computation. In the definition of TOC, nature of computation comes under automata theory and formal languages. Limits of computation comes under computability theory, and efficiency of problem solving comes under computational complexity theory. So TOC is the field of study that stands on three pillars of theoretical computer science, that are computability theory, complexity theory, and automata theory. So these three are the major pillars of theory of computation, and we will discuss each one of them in our next lecture. So now I hope that you have completely understood what is theory of computation. By this, we have completed our very first topic. Now we will proceed towards the syllabus of this course. The syllabus of this course is divided into 8 chapters. The first chapter is Introduction to Theory of Computation. Including this lecture, we will build a strong foundation of the subject so that it will help you to understand further topics in a better way. We will understand the topics like symbols, alphabets, strings, and introduction to languages and grammars. Our second chapter is Finite Automata. In this chapter, you will get to know how machines takes input and process that input step by step. You will understand the topics like DFA, NFA, conversion of NFA to DFA, minimization of DFA, and many more. Our third chapter is Regular Expressions. In this chapter, you will be understanding how patterns can be represented in its mathematical notation. The prominent topics for this chapter will be Arden's theorem, state elimination method, and Thomson construction algorithm. Our fourth chapter is Regular and Non-Regular Languages. Here we will understand what languages are accepted by finite automata and what languages are not accepted by finite automata. We will also understand the properties of both the languages. Our fifth chapter is Grammars, one of the most important chapter of TOC. Here we will see how languages can be generated using the set of rules called as grammars. We will study the topics like Chomsky hierarchy, CNF, GNF, parse tree derivations, and minimizations of CFG. After that, our sixth chapter is Push-down automata and context-free languages. Here we will understand one step higher than finite automata, that is push-down automata. We will see how to construct push-down automata, and we will also see the class of languages accepted by PDA, that are context-free languages. Our seventh chapter is Turing machines, the ultimate model of computation. We will understand how to construct Turing machines, and we will also discuss the properties of Turing machine. The eighth chapter is Type 0 languages and decidability. We will see the class of languages accepted by Turing machines, recursive language and recursively enumerable language. We will also see the topic decidability, in which we will try to find out the answer for the question, what problems are solvable by computers and what problems are not solvable by computers. So these are all the 8 chapters of this course. In this way, we have seen the syllabus. Now we will move forward towards the target audience. This course has been specifically designed for computer science students who are pursuing BE, BTech, BSc, and all computer science related fields. This course is also very much suitable for students who are preparing for their university examinations and have TOC as one of their subjects. The third category of audience is anyone learning TOC. If you are learning TOC and want to get a good grasp over the subject theory of computation and automata concepts, this course will be equally beneficial for you. So these are the target audience for this course. Now, as promised, we will see the course highlights. Our first highlight is topic-wise lectures. The course has been divided into topic-wise lectures so that each and every topic will be very much clear to you. The second highlight is simple explanations. Since most of the students say TOC is complex subject, so complex topics will be explained in the most simplest way possible. The third highlight is exam-focused approach. Since this course is the part of semester series, every problem and every concept will be explained in an exam-oriented approach. The next highlight is detailed problem solving. So whenever I will solve any numerical or conceptual question, I will solve that question using a detailed step-by-step approach for your better understanding. And the last highlight is quizzes and notes. You can access chapter-wise quizzes as well as notes on our website www.nesoacademy.org as well as from our application. So in this way, we have seen the target audience as well as the course highlights. So these were all the topics that we have covered in this lecture. This was all from my side for this lecture. I hope that you all are excited to start your TOC journey with me. Thank you, and I will see you in the next lecture.